Hello people, welcome back to Bharat Intern. Today we'll be creating another machine learning project on email spam classification. Hi people, we are finally back on my desktop screen and finally let's begin with our project. So let's quickly create a new folder on probably our desktop or whatever is your preferred place. So I'm making a new folder. I'm naming it email spam classification, which is what we are doing today. So email spam classification it is. So this folder will use this folder basically to create our IPynb files. Our Jupyter notebook will be stored here. We'll have our data sets, our models saved here, as well as the app.py code that we'll be needing further in this project. So now head on after we have created this folder. I'm heading on to Kaggle, of course. By now I hope you have created your accounts on Kaggle, which is basically a hub to get your datasets. So I've searched multiple CSV datasets for now. So email spam classification, we have CSV files, multiple you'll have multiple datasets on Kaggle, so you can look around and find a preferred one for you. Right now I'm going with this one, which so this is email spam classification CSV, which I have studied is quite complex. So I'm going with this one right now. It is SMS spam collection dataset. I'll be linking this dataset if you are using the similar one. So I'll link this in the video description. You can also prefer using this. So why I'm using this is because it is simple. The dataset inside this is quite simple and easy to go with. Whereas if you go with the proper email spam classification, so I've seen there are like multiple fields which we will be anyways removing them for the simplicity. So I'll go ahead with SMS. You can take any other data set and move ahead with the project. So I'll quickly go ahead, open my Jupyter notebook. Alright, so we'll get our Jupyter notebook loaded. So we'll have our untitled file. So you'll see in my downloads hopefully I'll have another email classification folder. Yes, so you see this untitled file right now. So the untitled file basically has my code. Again, I have pre-written it. So we have ease of explanation here in the project. Again, I'm so sorry I haven't been writing codes on screen right now because of the time limitations we have, because if I start typing all the codes, will easily get up to like 2 or 3 hours of video. So for now we are going with a pre-written code which I'll be explaining, and we'll soon be starting with codes that are written in front of you. So again, let me show you the folder content. Basically, you will have your PYNB notebook, of course, that will be saved, and you have app.py code, which I'll be explaining why we need it further. Now I have both the models stored here because I was experimenting with what CSV files or what datasets can be handled better. Now I have emails as well as spam CSV. So I have been working with spam.csv as my dataset right now. If you want, you can go ahead with emails. You will have similar procedures in the dataset as well. Now models.pyk and vectorizer is model.pkl and vectorizer is basically a model that we have created in our dataset. And again, while we are explaining the code, I'll explain you how those models were created. So let's begin with our basic code. So we are starting with importing NumPy and pandas as our libraries. We're going ahead with another code that basically imports pandas because I had an error loading my dataset. So I just use this try and accept. So basically, if there is any issue when you're loading your database, then this code will basically tell you that if it has successfully loaded it or not. So I'm using spam.csv. I have given the file path. Of course, so the error I was getting was that the CSV file had different encodings. Like it wasn't using the regular encoding. Instead, it was probably using UTF-8 or another one of these. So what I did is I gave the code a list of encodings, and I told it to try and experiment what encoding is working to get the file loaded. So it is trying UTF-8, Latin, ISO, all those kinds of encodings. So when it is attempting, it will tell us whether the encodings it was trying with the loop was successful or not. So at the end, it told me that failed to read the encoding with UTF-8, but it was successful it was successful with Latin 1. So basically the CSV file was encoded with this another kind of encoding. So CSV file was then later successfully loaded. Now I'm just setting df.samples and in bracket 5, which basically gives us the 5 sample of our data set. So we have here, so you'll see we have these random SR numbers. We have this column called V1 that has spam or ham. Now what is spam or ham? Spam is basically your message that is a spam, of course, and ham is which is not a spam, which is not a spam message. It is a legit message. So you'll see here ham says shit that is really shocking and scary. So you can see it's basically not a spam message and a serious one. The data set basically says that it is a legit message that way. Now we have another columns named unnamed 2, unnamed 3, 4, which are basically probably all null values. So of course we'll be removing those further when we are processing the data. Right now I'm again giving df.shape, which is giving me like the column versus the rows and the data that is there in the data set. Now these are the steps I jotted down. So basically what all things we will be doing with the data set. We have to do the data cleaning. We will be doing EDA, which is so in simpler terms EDA is nothing but exploratory data analysis, where we'll be analyzing the data, we'll be exploring if we could work with removing some columns or not. Next we have text processing. Of course we'll be pre-processing before we load the dataset in our app.py code, and of course we'll be building the model at the end. So once we are done building the model, we'll use the same model to later predict if the message or the email we are typing on our main website that we'll be creating, so if it is legit, if it is spam or ham. Next we'll evaluate, of course, and if there's any improvement required, we'll improve it, and of course we'll create the app.py code, which will basically create our website, and we'll deploy it, of course, using probably we'll use Streamlit, of course, the most common way we could get the website loaded. So we'll begin with our first step, which is data cleaning. Now df.info of course gives us the information in the dataset, and as I said, we have v1 v2 columns that has 5572 non-null values, and they are all objects. Now again we have these unnamed 2, 3, 4, which has 50 non-null, 12 50 followed by 12 followed by 6 non-null values. So you can see basically these column number 2, 3, 4 are not that important. They just have like 50, 12 and 6 values, as you can see, and all the rest are null values, so probably they are not of any use. And of course you have your D types, what is your data type, and memory usage. It's a small file, it's just 217.8 kbs. So again, like I said, we are dropping the unnamed 2, 3 and 4 columns because those have like extreme amount of null values and they're not really important. So we're dropping the last 3 columns. We'll be using df.drop columns, and we're giving the column names here, and in place true. So df sample again, and you will see the last 3 columns are removed. So we have v1 and v2. Now again, so v1 and v2 was quite difficult to handle for me because I was getting confused what exactly is v1 column saying and v2 is. So I'm renaming those columns with df rename, where v1 is then replaced as target. So if it is a spam, so we'll target it as spam, or if it is not a spam, if it's not a spam, we'll target target it as not a spam message. And v2 is basically our text message, of course, so I'm replacing the column names such a way. Again df.sample I'm taking, and you will see the column names are now changed to target and text. Alright, so now I'm using sklearn again. I'm importing it, and I'm using label encoder here. So what this will do is we're basically putting transformations on our target column, which is spam or ham. Now if you check again with df.head, you'll see it now displays as zeros and ones, so it doesn't display spam or ham. So when you're working on building a model in the future, so using 0 and 1 would be more approachable than using spam or ham. So zeros and 1 is what I'm changing the labels from spam or ham to zeros and ones, which will be easier to analyze and like analyze and of course study later. Now I'm checking out the missing values. So df dot is null dot sum will basically tell us what are the null values in the columns. So as you can see, target has 0 null values, text also has 0 null values, which is good for us. We have all proper values now in the data set. Now we are checking for duplicate values again. Similarly as is null, we are doing df dot duplicated dot sum, which will tell us what are the values that are duplicate, like same values. So 403 was the number we got, which is workable. Okay, so which is a good information for us. I'll note it down again. Now we're removing those duplicates because having duplicates might confuse our models, or might bring some problems with the model further on. So just hit df equals to df dot drop duplicates, and so once you are done with duplicated removal, you'll again go to df dot duplicated dot sum and you will get 0. So basically 403 values, duplicate values, are now removed. Again I'll hit df dot shape just to have a look again. So earlier df dot shape gave us the value 5572 by 5. We removed the last 3 columns, so now it is giving us 5169 by 2. So the number of values is reduced because the duplicate values are now deleted, as well as last 3 columns. Alright, hope we were clear till this step. A very basic step. We have just refined our data set. So we'll be moving to our next step. We'll be going to section 2, which is data exploration, or if you want you can call it as EDA, which is exploratory data analysis. So we'll begin with our second section, which is data exploration. Hope we are clear till the previous section. Now data exploration, again I am hitting df.head to just have a look at my data set again. So we have our target and text columns with the characters and zeros as one, representing ham and spam. Okay, so next what I'm doing is df target dot value count. So I'm counting the values of both the columns. So ham, sorry, not both the columns, the ham and spam value counts. So you will see a 0, which is represented as ham, has 4516 values, whereas spam represented by 1 just has 653 values. So what this basically tells us is, visibly we can figure it out that our data set is has a really big gap difference with the value counts. So the data set is quite imbalanced here. There are a lot of ham values and a very few spam values. I just to clarify that I'm just using matplotlib and plotting another pie chart that will basically show us we're targeting labels ham and spam. So you'll see 87.37% is ham in the data set, and 12.63% is the only value of spam. So yes, visibly now you can figure it out that the data is a little imbalanced, fairly imbalanced, and we'll have to note it down somewhere, like I have done it here, and we'll try balancing out the data further when we are building the model. So next what I'm doing is I'm importing NLTK, quite a popular library. If you are not aware of it, NLTK is basically natural language toolkit. This library, along with NLTK PUNKT, which is another module, important module of NLTK library. What this basically does is it will use like an unsupervised way where your characters, your abbreviations can be looked at from your data set. So NLTK will help us separate out our data in forms of characters, different punctuations, or probably different sentences or words in that matters. So later on when you check out the code, you'll understand the use case. So next, if you see here, I'm using df num characters and text. So we are taking out number of characters from the data set. So you see we have different sentences, punctuations here in the characters. I'm just taking out different characters. Again, if you see df.head, so you'll see a new column has been added here, along with besides text you have num characters. So what this is giving is key from this text how many characters are there. So this thing has 111 characters, followed by 29, 155. So all these character counts are basically there in the new column. So what I'll be doing is using NLTK. Later on I'll be creating different columns with a number of characters, number of words, or different sentences. So that will basically help us analyze the data set further. Now again df dot head, here in the above code what you will see is I'm taking out another column for number of words here. So it will give us a word count. Again df number, I'm naming the column num underscore words, and I'm targeting text here. So you'll see, okay, apply lambda. All right, so you're just using NLTK to tokenize it. So here you have another column added, which is num words, and you'll see from the text these are the number of words you have, these are the number of characters, words, followed by, similarly what I'll be doing is adding another column called num sentences. So in this text you have two sentences, followed by this has two sentences, one sentence. So that way you can just have a look at the data set better. And if you could figure it out, rather than those unnamed columns we had, these are more helpful columns now that we have added. Okay, now what I'm doing is I'm taking df, again number of characters, words, and number of sentences. I'm just describing those columns once. So you'll see our minimum is 2000, minimum is 2, which is okay. Minimum number of characters are 2, number of words are 1, and number of sentences is 1. So you'll see 50% of characters are between like approximately 15 words and 1 sentences. You can just figure it out like how your data set is structured. So df.describe basically just gave us the description of all the 3 new columns that we have added. So we could figure out how many characters, words, and sentences we have in the data sets. That will basically help us analyze it further. Next, what we are doing is we are targeting ham specifically. So so you can see the 3 columns added has so many number of characters. Character count is 4516, which we have seen earlier as well in ham. The word count is this, and the sentence count is this. Alright, for like the mean number, standard deviation, 25, 50, and 75 percentage, and your maximum count all can be seen here displayed. And next we are targeting spam. You will see our values that we have seen earlier, which is 653. 25% of the characters are 132 are the 25 percentile, 75th percentile is 157, and so on and so forth. Alright, now just all the descriptions are done. I'll be just plotting out graphs just to take a look at the data better. Visually, when you look at data in form of graphs and all these kind of graphs and visually when you take a look at these graphs and plottings, you will understand the data better rather than these descriptions. So I'm again importing Seaborn, and I'm plotting this I'm plotting a histogram here with target as my characters. What I'm doing is I'm targeting 0, which is ham, for the number of characters. Next I'm targeting spam for the number of characters, and I've defined spam with the color red. So just it's easier to figure it out what is spam and what is ham. So you can see the count of ham here. The character count is much higher compared to our spam character count. Oh, sorry, my bad. So the character count for ham is figuratively more has more characters if you see on the histogram. Similarly, I'm targeting more columns now. So characters is done. I'm targeting now words in ham and spam, and next I'm targeting. Alright, so words and characters, that is all. So you can just have a look at the difference in the histogram, the word counts, the character counts, quite a change in the histograms. Next I'm just doing a pair plot here. So I'm using the text again. Right. So what this will do is it will give us number of characters, words, and sentences together, and you can just have a look here. Our ham is again 0, followed by spam as 1, and just have a look at all the graphs, and you can figure out the data spreadings all over the data sets, right? Next, what I'm doing is I'm plotting another heat map. Heat map basically giving us our 3 columns, that's characters, words, and sentences. So you can use all these histograms followed by pair plot and the heat map to analyze the data further, have a look at the value counts and stuff. Basically, when I say you can analyze the data set using all these plots, right? So looking at our pair plot, what we can do is like we can analyze individual plots. So you can see, we can compare number of characters by number of characters from spam and ham. You can compare number of characters by number of sentences with the target 0 and 1 again. So you can see, I mean, the more linearity there is in a graph, the more accuracy you can get. So that is basically what these graph will help you. It will help you analyze the data, and even when you're creating models, right? Now if you look at the heat map, you'll see our target 1 and 0. So 1 is basically, we all know by now that we're targeting. So once again, 0 was ham and 1 was spam, correct? So we're targeting if our email has to be classified as a spam or not, right? So our target should be 1 or 0. So when you're looking at this, where target is 1, so what we'll see is we'll check out if number of words, what is the correlation between number of words, number of characters. And if you have a look at the values here, you will figure out there's a strong correlation between all three columns. So of course, when your number of sentences or maybe a number of words or characters increases, there are high chances that it will be classified as spam, because the model will somewhere try to figure out that it's a very long sentence, and if there are repetitions in characters or words, then it will probably classify it as spam. That is what, even when we are reading a message, it is our tendency to look at it in that way. So here, of course, when you see there's a strong correlation between all the three possible columns we have. So when you're figuring out to create a model, right, this will give us information that what one column can be used to later on create a model. So we can't use all three of them because there's a very strong correlation in it. So if you look at it, number of characters have 0.38 relation with the target, number of words has 0.26, followed by sentences with 0.28. So when you are possibly creating a model, you'll choose number of characters as your value for creating the model. So because it is closer to target, has the most correlation with it, and chances of confusion are less when you're creating the model. Alright, so this is what plotting and representing the data visually will help you out with. So we can end this section here. We'll just go with the data pre-processing now. Alright, so we stopped at data pre-processing and we'll pick it up from there. So the section entirely is what I've listed it down here. So what we need to do is we'll take our text that we have so far written in our data set, and we'll convert all of the characters into lowercase first of all, and then we'll tokenize them. Tokenization is basically just your breaking down your sentences into words, that is tokenization. And you're removing special characters from the text, of course, to simplify things. Removing stop words and punctuations. Yes, again, punctuations don't really add up in the meaning of a sentence when you're taking it into a perspective of an model building. So we'll remove those. We'll be doing stemming. Stemming is basically when you have a word like in different senses. For example, you are writing dancing, so dancing, danced, or I was walking, I walked. So all those words will be taken as a baseline. So walking will be converted to walk, dancing will be converted to dance, danced will be converted to dance again. So yes, that is stemming. So we'll be using NLTK again, our library that we used above. So we'll take NLTK. We are experimenting with multiple libraries, multiple modules. So we used some other module above. Now we are using stop words, and we are also taking help of port streamer to again stem our characters. So we're using, I have imported those libraries. We are using these models. In case you haven't downloaded, you will have to download it. The simple command will help you do it. Again, I'm using PS as port streamer, and so what I'm doing is, so this entire block of code at line number 112, what this entire block does is you take a normal sentence from our data set. Suppose we are taking this sentence: I'm gonna be home soon, I don't want to talk about this stuff anymore tonight, okay, I have cried enough today. So this is our sentence right now, which is one of the sentences taken from the data set. Now what this will do is transform this text with whatever pointers we have just seen. So I am gonna be home will the capital I should be converted to small I. So everything will be lowercase, everything will be tokenized. Once you have individual words, you will be the special characters will be removed, stop words, punctuations will be removed, and stemming will be done. So for example, if you I can't find a word that can be stemmed here, but for example here down, if you see an example of stemming, you on line 51 you will see that the word loving is converted to love. So that basically, if you write any other word here, so if I go ahead and write walking over here, so it will give me walk as an output. So that is basically stemming. Now what this entire block is doing is it is basically tokenizing over here. Then we are appending the tokenization and all the changes that we're doing over here. And now if you see the output of this code, so this sentence, I'm gonna be home, this sentence is now converted to this, which is gonna home soon, won't talk stuff anymore tonight. So if you see, I mean right now if you look at it, it won't make much sense, because you're like, where is I am and all this stuff. So that is because if you see, you have punctuations here, you have these semicolons, commas, and all that stuff that will be removed. And for example, right now if I remove this entire sentence, and right, so if I remove this entire sentence, I write, hey, what's up, all one second, all good, question mark. So if I write this, the expected output should be that the punctuation is removed, the special characters or whatever is removed, and you get, hey, what's up, all good, and no question mark, right? That is what we expect. But the thing is, when you're using NLTK, right, it will only give you what's up, good, because you have hey that is connected to the special character, and good, which is connected to this question mark. So I mean, or all, whatever, because all has been taken as, I think it has been stemmed then. So what's up good is the only output you'll get. For example, if I try changing it to hey and all good, question mark, then the output will only be good. So that is basically how NLTK works. It gives you only words that it thinks is necessary and that has a meaning in the module. So this entire sentence has only been converted to this, and words like anymore, right? So anymore, the E has been cut it off. That is because the normal functioning of the normal functioning of the NLTK library is such. So that is how you transform your sentence from something that a machine language could understand, and the model could be based on that, right? So again, I'm taking df text. This is our original text. I'm doing stemming over here. Just an example. I just wanted to show how stemming would work. And now I'm transforming. The main agenda why we did all this transformation of text is because we could we could get this done in our data set. So again, like we added these 3 columns here, I'm adding transform text as another fourth column now. First, second, third, fourth, fifth. Okay, this is our 6th column now with our transform text now applied in this column. So all the text you see here is the transformation of our original characters. Okay, now that we have implied the transformation on our main data set, we can go ahead and just picturize stuff. So all these steps basically, where we picturize stuff, we plot graphs and have a look at how the data is visually represented. Even if you skip all these steps, right, you can very easily build a model. But then, just for a clarity, when you're creating a project based on having classifications and stuff, it is good to have clarity in your own mind. That is when you know how the model works in the backend, and you can figure out things then. So again, what I'm doing is I'm just importing word cloud from word cloud, and I'm taking I've set the width and height for good visibility. I have taken transform text as our target here, and what I'm doing is I'm taking spam first. Yes, so I've targeted spam here. So these all the words that you see: free, you, text, reply, text, call, please stop, mobile. So all these words are basically the highest amount of the highest frequency of words that are used in our spam dataset. So the 613 approximately word count that we had for spam, so these are the words that are most frequently used there. Now same way I am targeting ham now. So these are the words you see: come, call, time, think, got are basically the highest frequency of, I mean, the words that are in highest frequency in that data set. So now I'm again just having a look with the df head. Our transform text is here. Now what I'm doing is I am just having a spam corpus here. So what spam corpus will do is it will tell you what are the total number of words you have in spam. So the total number of words or character that you have in the entire spam database of 613 approximately is approximately 10,000. So those are the individual characters you have in the entire spam database. Now I'm just representing all of that again as in this chart. So if you see in our word cloud again, all these words like free, text, call, all are here represented in this chart as well. So you will see call, free, text, all these words and the frequency. So you will see call has the highest frequency in spam again, just for the clarity, I mean just so you could understand what exactly is running around in the data set. Now same way I'm having another ham corpus where you get the characters that are there in ham. So those are around 35,000. So 35,394. All right. So and then another, again I'm plotting it in a vertical graph. So you see all the words listed down over here, and yes, you get the most frequency. So U apparently has the highest frequency in ham. Alright, now the final step. This is not exactly vectorization, I have just given it as a comment. So even if you remove it, it's fine. I was just looking at the data set. So now what we need to do is vectorize it. So if you see here, we are using characters which are like alphabetic characters over here. Now we need to get this into numeric characters. That is because when you're using this into the model, you can't go with alphanumeric, like you can't go with alphabetical values. So you have to go with numeric values. You have target as numeric values, but your text is not. So you will have to vectorize it. Right. So that is the plan. So forth. The section basically ends here. The entire section of data processing was basically, you have to transform the text, and we just had a visual representation of the highest frequency of words, and we then combined it with our main data set. So that is all for this section. Next we are going to our final step where we are building our model. We'll be saving it again. So building a model is quite a critical step here, because we are done with all our transformation, our processing, refining of the data set. Now I am just experimenting here with different kind of modules that different type of algorithms actually that will help us build this model. So I am just using count vectorizer, I'm using TFID, and I think I've used another one where I was just checking out which model will give us the highest accuracy. So count vectorizer, I used it first, and then I think it gave a very poor performance, approximately around 50%. Yes, so 0.5 was using Gaussian NB. So naive base is what you're using here. So using Gaussian blur naive, I could only get like approximately 50% accuracy, and which then later I used multi-normal, and I also used Bernoulli's, which gave me a better accuracy. Approximately I think we went to 99% then. So yes, I just experimented throughout this code. You will see I have used count vectorizer, TFID, then I used transform text here to then later I used the transformed text to vectorize stuff. So yes, X shape, if you just click on X, if you just type X, you will get this array. So X shape will basically tell us, one second. So X shape will basically give us our 5169, which was our total count, and which has 3000 word count. Either it's word count or it's character count. Right, so we use all this. We used naive basis, which is Gaussian NB, we use multinomial, we use Bernoulli's, and we just did a trial and error with GNB, MNB and VNB. So GNB basically gave us like a pretty low accuracy here, and we worked upon it. We later used MNB and BNB as well, which then dropped us at 99% or 98%. So 99% is quite a fair amount of accuracy, so we can move ahead with this. So yes, after testing all the modules, all the data set, all the transform text we came across with. Okay, so this throughout experimentation, I basically just concluded it that we'll not use count vectorizer because the performance we got on our dataset wasn't that great. I mean that workable. So I just went ahead with TF vectorizer here, and we tested modules. We used these naive bases GNB, MNB, and BNB. So I was confused. Like BNB gave us good accuracy, but if you see here, if you see the array here, right, you get a few values that are, false positive values are taken into consideration and in BNB. Whereas if you see MNB performed better, it has approximately 97% accuracy. With if you see the array, you have zero false positives, so that is good for us, and that is why if you see, I have commented it already. Like we are using TFID and MNB base. So MNB knife base we went ahead with. Now just to get even like more secure with the modeling, I went ahead and like use some more machine learning models here. I listed down all of them, whatever could be used. I had XGBoost, we used logical regression, multinomial, NB again, decision tree classifier, neighbors classifier, random forest classifier, all these extra machine learning models. I just listed it down and just took like a test. I listed it down, classified it, and had another test where you'll see, right. So this is where the entire performance of all the ML models that I mean for accuracy, precision, everything is listed down in this and I get a list of their accuracy. So for SVC we got accuracy as 97%, precision was 97. Again for KN we have this accuracy, precision was pretty good, like this is perfect precision, we got 1 as value. Even NB performed well with 97% accuracy and precision as 1, so we can call it 100% precision. And yes, similarly likewise all these machine learning models have their different precisions and accuracy. So that is what helped me shortlist like how are we going ahead with the model precision and all that stuff. So now again this line of code is basically checking the performance of all of them. I just had a table formed there. So KN with accuracy, like whatever is the best accuracy and precision is on the top of the list, so I can shortlist it from there. Alright, so again checking the performance here of all the algorithms, making another list here. So the accuracy value, I was checking it and then I compared both of these table with a chart here. So I could scale it, I could visually see what all can be went ahead with. Now after we are done with checking out all the machine learning algorithms models possible, it's time to improve the accuracy a bit, like get our model improved. We can't go ahead with all the modules from the list, so I'll shortlist the best one. So I had to pause it a little bit and I had a look at why the model improvement, what I did in the model improvement. So basically what we're doing is if we have like 6,000 words or 10,000 words like we saw earlier as our spam and ham, so we can't go ahead with all 6,000 of them. So while improving the model, right, you can't take entire character length for your model fittings. So what I just experimented with the number of characters that we could include, and then if you see on the top right, we chose a number already and I had to rerun the entire model. Correct. So here when we are taking max features, right, we use TFID vectorizer and the max length that we are taking for characters is 3000. I tried it with 2500, 2000, even 1000. So the best middle point I could find is 3000 character length, where we'll be further experimenting with all of them. So this entire section is basically scaling of the model. One second. Great. So this entire section was just scaling it up. I tried re-performing all the steps again and did this extra column where I added your scalings. So had this accuracy precision model in a tabular format. And yes, so basically just scaled out with a limit, couldn't go more than 3000, and tried if the precision is increased. So yes, this is just scaling up and trying to see whatever fits in model building. That is all. Now is the main part where we are just classifying it and we are saving the model, the very last step of our ML project. All right, so we are at the very end of our model. So the final steps basically have a voting classifier. Since we use a lot of models to train and check the precision and accuracy with our characters. So yes, just use another voting classifier to check the precision for all the SVC, multinomial NB and extractive classifier, just to check the precision and accuracy one more time. Didn't give me a very definite answer, but then yes, accuracy being 99 and 98 and precision being 99 was a good figure. I also tried using stacking classifier, so it's just slightly different from voting classifier. In stacking you have like you get a different picture from what you get from votings. So similarly it gave me accuracy 97 and precision being 93. Just went ahead with voting classifiers numbers, and yes, imported pickle, used vectorizer.pkl with right binary and model.pkl with right binary again to save my model. You can refer this again. I have just given those training codes here and then saved my model here. So if you see, saving it with the TF-ID vectorizer and knife based models. So vectorizer.pkl is saved and model.pkl is saved. So once you check in your folder, right, you will get these two files added along with your notebook and with the dataset, of course. So now we just need to create one app.py code file, and then yes, we are good to go. So the model is trained and the ML project is completed and the models are saved on our current directory, and we can go ahead with the app.py code. So I've opened VS with the folder and all my files including the model, the dataset and everything is here, and I've created another file called app.py. Now let's just begin coding. I'll just import the necessary libraries. I'll import Streamlit as st. I'll import pickle. Alright, and then so let's comment it out. Let's load our model and our vectorizer file here. So let's load and save our vectorizer and our knife model. So what I'm doing is I'm doing tfidf equals pickle.load, and in bracket will open our vectorizer file here. So vectorizer.pkl with of course we will open it with read binary, and yes, hopefully we're good to go there. tfidf pickle load, okay, open vectorizer, and in the next line, so we need to load our model. So then model equals same format, so model equals pickle.load and open our model.pkl file as read binary again. Hope all the commas and brackets are good. All right, we're good to go. So next one, we have loaded our vectorizer, we have loaded model. We need to now do the Streamlit coding. Now I've commented out saving Streamlit code, by which I basically mean that all our user interface, like whatever will be present on the Streamlit website, should be there over here. So I'm going ahead with st.title and I'll name it as email spam classifier. So yeah, that will be shown as a title on our website, and then I'll give out like input fields. So I'm defining it as input underscore SMS or whatever, like input underscore message or input underscore email, and equals, and I'll go ahead with st.text area because we need like a good amount of text that can be entered there. And so I'm going with text area and enter message, so you'll have that displayed in your box wherever you're entering the message. Now what I'll do is, if st, I need a predict button here, so st.button, and just in semicolons, in those commas you write predict, and yes, we're good to go. What I'm now in my pre-processing steps, I need that transformation code here, which we also used in our PYNB notebook, where we basically had those transformation of our text. I'm taking transformed underscore SMS that equals to transform text, and you're doing your input here. Now pre-processing has this. Next I need to vectorize. So I'm taking again same structure, vectorize underscore input, and tfidf of course dot transform, and I'm taking the label transformed underscore SMS. Now while predicting, I'll get result equals model dot predict with vectorizer underscore input and 0. So 0 was basically a spam and ham, how we indicated it with 1 and 0. So if it's spam, if we are predicting it as spam, then it should go as in our display, it should show as if results equals 1, which is spam, then write st dot header as spam. If or else if it's not, then st header, it's not a spam. Now obviously when you are importing Streamlit, right, you first need to install your Streamlit if you don't have it installed. In my case, I already have it, but if you don't, use pip install Streamlit and you're good to go in your terminal. It will take a bit of time to install everything, and you will be good to go. So what I'm doing here is Streamlit run app.py, which will basically take you to the website on Streamlit. And yes, so the functioning is going good. I mean, the looks are okay. Your title is here, your enter message is visible, but I'm doing a silly mistake here. I'm just typing in my command first, I mean typing in my message first, and I'm trying to predict it, but if you see, I have a traceback error. So let's just quickly fix it and be right back. Okay, so here you see we are back on our VS Code. So what I did is we imported our Streamlit, we imported Pickle, we did our model loadings properly. Now we directly jumped on this part of Streamlit where we had our title, our predict button, and our pre-processing and all that stuff, where we are basically predicting it directly with our vector input and stuff. But missed a very crucial part where we basically need to add that functionality, add that transform function that we had on our pynb as well. So I basically thought we are directly fetching it from there, but of course we need to mention it here first. So post we stopped at this part, and then later what I'm doing is I also imported this sklearn again, and imported tfid vectorizer first. All right, so next what I did is we're basically defining this function here, our text pre-processing, where I imported an NLTK again, NLTK corpus. We use stopwords and port streamer. So I basically copied all the code from our pynb itself, where we used our NLTK download.stopwords. If you could trace it back. So again, ps port streamer. This is what we already discussed in our pynb as well. So right, this functionality has to be defined here in our VS Code as well. So I copied that code and pasted it here. Now again, defining transform text, and we are converting it to lowercase. Then we are tokenizing it. Then we are removing the special characters and retaining the alphanumeric words with text equals to word for word in text, and if word then is was if it's alphanumeric or not. All right, then we are doing removing stop word and functions, sorry, punctuations. And yes, so we are defining it here again, and later on we are just stemming around, right, stemming it, and yes, I think we're good to go there. Right, and then we come back to our Streamlit code, and everything rest is same. You just have your email as your title, email classifier, and the button is there. All right, all the rest of the code is same. We're just predicting it now and displaying the result. So now just let's open a fresh terminal, and in the new terminal now we can type in our command, which is Streamlit, and run app.py. So I'll go ahead, write that, and once I hit enter, it will take me back to the Streamlit application. Right. Now that I'm on the portal. I'll just refresh it once, and now let's test it out. I'll write something important. Hi Yash, this is important. uh, and okay, I'll predict it. Okay, it shows not a spam. Let's refresh once again, and okay, now let's write something spamish. So I'll just copy paste something I found on the internet which looks like spam. So wait, okay, there's two twos, so I'll remove one. And now let's predict. Okay, it shows spam. All right, so looks like the model works pretty fine, and that marks the end of this project. Thank you so much for watching it. Thank you.